Hello! Welcome to today's lesson on electric fields. Today, we will understand what electric fields are. Then we will examine the factors affecting the size of an electric field. So far, you have become familiar with current and static electricity. You understand the behavior of electric charges, including how they can be transferred and how they interact with each other. Imagine you have a balloon that you've just rubbed against your hair. By doing this, you've transferred some electrons from your hair to the balloon, making the balloon negatively charged. Now, let's think about what happens around this charged balloon. The charged balloon creates an electric field around it, which is an invisible force field that can exert a force on other charged objects placed within it. The electric field exists in the space surrounding the balloon, even if there's no other charge nearby. However, instead of pulling objects, an electric field exerts a force on charged objects placed within it. This force can either be attractive or repulsive, depending on the sign of the charges involved. For example, two positively charged objects will repel each other because like charges repel. Conversely, a positively charged object and a negatively charged object will attract each other because opposite charges attract. This interaction happens without the objects needing to touch each other. They influence each other through the electric field, making it a non-contact force. Now suppose you rub another balloon on your hair such that it also gets negatively charged. If you brought them close together without them touching, you'd notice that they repel each other. This repulsion is due to the electric field created around the charged objects. The electric field of one negatively charged balloon repels the other balloon because like charges repel. The size of an electric field also depends on two main factors. The first of these is the amount of charge. The larger the charge on an object, the stronger the electric field it creates. This is analogous to how a more massive celestial body, like Earth, has a stronger gravitational pull compared to a less massive one like the Moon. For instance, if you were to rub one of the balloons mentioned earlier for a longer time, more electrons would move from your hair to the balloon, hence increasing the charge on it and leading to a stronger electric field around the balloon. This would lead to a stronger repulsion between the two balloons. In summary, a highly charged object can exert greater forces on other charged objects within its vicinity. The second factor affecting the size of an electric field is the distance from the charge. The strength of the electric field decreases with increasing distance from the charged object. Just like how the gravitational force weakens as you move away from the Earth, the electric field becomes weaker the farther you are from the source of the charge. The closer the balloons get, the stronger this repulsive force becomes, and vice versa. In today's lesson, we delved into the concept of electric fields and their significance within the broader context of electricity. We began by defining an electric field as a region around a charged particle where a force would be exerted on other charges. We then discussed how the strength of an electric field is determined by the amount of charge and the distance from the charge. In the next lesson, we will build up on this by looking at electric field diagrams.